we are going to talk now about the native VLAN. So if we take a look at our configuration as it is now, we can see that it says trunking native mode VLAN 1. What does that mean? What is the native VLAN? So I'm going to give you now a couple of minutes to form your answer, so please try to type it out. What do you think the native VLAN is? Some of you have some good understanding of the native VLANs, and some of you have a little less good understanding of the native VLANs. And as I said, this is a cause of mass confusion. And even the author of Juniper's switching book got it wrong. So don't take it the wrong way when I tell you you are wrong. So I'm going to try to explain what the native VLAN is. So let's say that we have switch 1 here, and we have switch 2. And let's say that to switch 1 we have R1 connected, and to switch 2 we have R2 connected. This is fast internet 0, 0, and this is gigabit 0, 0. This is fast internet 0, 1, this is fast internet 0, 2. Now, between switch 1 and switch 2, we already have an interface, which is fastnet 24. And let me build two VLANs between R1 and R2. I'm going to have a red VLAN, which is going to be VLAN 10, and I'm going to have a blue VLAN, which is going to be VLAN 20. I'm going to have a third VLAN, VLAN 30, which is not going to be present on R1 and R2. Now, my goal is to have the communication between R1 and R2 in both red and blue VLANs. So here is blue one, here is the red one. Okay, and between switch 1 and switch 2, I'm also going to be allowing the green one. Okay, now, between R1 and switch 1, I want VLAN 10 to be native. Between R2 and switch 2, I want VLAN 20 to be native. And between switch 1 and switch 2, I want VLAN 30 to be native. Now, I'm going to have IP addresses on sub-interfaces here and here configured in VLAN 20 as 192.168.20/24.1 and .2 here. And on VLAN 10, I will have 192.168.10.0/24. So basically, I'm using VLAN 10 as native here, VLAN 30 as native on the trunk between switch 1 and switch 2, and I'm using VLAN 20 as the native between R1 and switch 2. My answer here is, my question here is, will this work? Am I going to have communication between R1 and R2 with this setup as it is? Okay, let's give it a try. So what I'm going to do now is I'm going to bring my notepad and I'm going to start configuring. So I'm going to make it a little bit bigger here so that I can fit multiple configurations. So the first one that I'm going to do is going to be for cat1. So here I'm going to have, first let's create the VLANs. So I'm going to create 10, 20, 30. Then I'm going to configure the ports. Let me first delete all those other VLANs. So no VLAN 100 to 199, in a case they're still actually not sure which I created. So interface fastnet 01 here needs to be switch port trunk encapsulation.1q, switch port mode trunk, switch port trunk allowed VLAN. Let's just allow VLANs that I need, 10 and 20. And I'm going to have switch port trunk native VLAN 10. So this will be the configuration facing R1. Now on my interface facing facing cat2, the configuration is going to be pretty much the same. Let's allow 30. Let's actually allow all the VLANs. Just set the native VLAN to be 30. So this would be the configuration. Why doesn't this work? I think my text expander actually died. Okay, so let's configure cat2. So just going to do cat2 here. Pretty much the same configuration. This is 2, except that VLAN is native 20 here. Now let's configure R1. So on R1, I'm going to have interface fastnet 00, no shutdown. Then I'm going to have interface fastnet 0010 encapsulation.1q10. This is native VLAN. And I'm going to have IP address 192.168.10.1, 245.245.245. Actually, 0 was there. And I'm going to have subinterface for 20. And this one is not native. So the next thing is the configuration on R2, and this is a gigabit interface. So let me just modify these. And 20 is native. So these are the configurations that I'm going to have on my switch 1, switch 2, R1, and R2. Let's start one at a time. So I'm going to bring my R1 and R2 to the mix here. So let me just bring them like this. So R1, R2. So here is my R1. Let me start by configuring that. This goes in. Let's do R2. And let's do cat1. Oops, small mistake. Oh, VTP mode server. Let's change it to server so that we can actually delete those VLANs that we don't need. Let's do cat2. Maybe it will be faster if I bounced interface fastnet 24. I'm just going to do shutdown, no shutdown there. Okay. So now if I go to R1 and if I say ping 192.168.10.1, I can ping myself and I can ping 21. Now, can I ping 10.2? What do you think? Yes or no? What do you think? Okay, I'm pinging 10.2. And it appears not to be working. So what could be possibly a problem here? What do you think? Where would you start troubleshooting this problem now? So these are the configurations that we did. You may have seen me type them out, but something doesn't work. So where do we start? Here's your troubleshooting ticket. Give me an idea. Show switch port. Okay, so I'm going to type show switch port interface fastnet 24, and sorry, wrong command. Maybe you meant show interface fastnet 24 switch port, so let's run that command. So it says administrative mode trunk, operational mode trunk, and it says here administrative trunking encapsulation.1q and operational trunking.1q, and we have VLAN 30 as the native VLAN. So would you like me to run the same command on cat2? There we go. Administrative trunk, operational trunk. Operational trunking encapsulation.1q, same as configured, and we can see that the trunking native VLAN is VLAN 30. So what's next? Show int trunk on both switches. Very good. So what we should be seeing here now is that this is cat1, that fastnet01 is a static trunk, it's 802.1q, it's trunking, and the native VLAN is 10. Fastnet 24, fastnet 03 is irrelevant. That's the one facing Wireshark. So here we have 24, it's a trunking mode on, it's 802.1q, it's trunking, and the native VLAN is 30. And we can see that on port 1, VLANs 10 and 20 are allowed, and on port 24, all VLANs are allowed. Let's take a look at cat2. Show interface trunk. Here we have fastnet 24. Okay, Marco has made a stupid mistake, and I'm just going to shoot myself for it. The problem here is of my own doing. And this is not something that you can troubleshoot right now because I have made a silly mistake. This is supposed to be gigabit interface 01. So let me correct my configs. And we are going to go back to troubleshooting. Please don't give me laughs now, which you haven't been doing, but I am fully expecting to hear them. So what I need to change here is going to change these to defaults because I don't need these. But what I do need is gigabit 01 with the same configuration. So this shows you a value of actually doing configurations in Notepad because I can easily correct my own stupid mistakes now. There we go. Now the interface change state to reset. Let's see, show interface, gigabit 01. Aha, there it is. Show IP route. I have the routes now. Let me try the ping again. So I'm going to ping 10.2 with pretty much the same result. And I'm going to ping 20.2, which worked. So what's the problem? What do you think the problem is? Okay, if I try to ping again, it works. So what do you think was the problem? Why did it not work the first time? So here I have the same ping that doesn't work, and here it works like a charm. What could be the problem here? And by the way, let me try it again. So 10.2, 22. Works like a charm every time now. Well, it's not the MAC address table that is the problem here. It's the spanning tree. Now, I never mentioned spanning tree in this scenario, and we were just ignoring the presence of the spanning tree. But you know, when the interface comes up, the port needs to go through the learning phase and then the listening phase, and only then makes change to or change state to forwarding phase. Well, this is an unusual setup. This is not some everyday setup that you encounter. So you are already unsure, is this going to work or is this not going to work? So you configure it, you paste in the configs just like I did. Even without the mistake, the result would have been the same, without the mistake in my config. And we would get no ping. So you are going to start troubleshooting. Why am I not getting the ping? Are the ports configured as trunks? Am I allowing these VLANs? What are the MAC addresses? And you might spend troubleshooting for about 10 minutes. In my last class, they actually spent about 15 minutes troubleshooting this problem. When I finally told them, stop, you're troubleshooting a non-existent problem. They all gave me very, very unusual looks. And then I went to R1, pinged R2, and ping worked. And everybody was confused. Now, this is what I was telling earlier. You must not forget that there are other processes on your devices running. You need to know what are those interactions. So 2 switches and 2 routers is not only about 2 switches and 2 routers and native VLANs. It has more stuff to it. There is spanning tree that needed time to converge. So never forget those things. There could be other technologies that are actually making something not work. But going back to the native VLAN, this works like a charm and is actually a legitimate setup. So in order to explain why it works, I'm going to zoom in to switch 1 for just a little bit. So let's say that switch 1 here is a very, very silly switch that has a very simple backplane operation that operates like a bus. So every single port here is somehow connected to this bus. So we have my ports. This is port 1 and this is port 24. Now, let's say that I have some other port here. Let's say port 3, which is what I have. So on this side here, when the frame arrives, and if it arrives in a native VLAN, what we mean by native VLAN, this frame arrives without the tag. So this is just an empty frame. There is no marking to indicate to which VLAN this belongs. Now, when this arrives on this port here, port number 1 is configured to treat untagged frames as frames in VLAN 10. So what's going to happen, before this goes back on the backplane of the switch is going to add a VLAN tag 10 here, and it's going to send it on the backplane. Now, based on the MAC address, we know that this frame needs to go out of this port here, and it arrives with the tag 10. Now, switch port 24 is configured that the native VLAN is 30. So we are now looking at, does the tag on this frame match the native VLAN? The answer is no, which means that this frame is now going to go out of this port with the tag. Now, let's say that the return traffic comes back. Now, the return traffic comes back, and this time it arrives tagged. So we are receiving the frame tagged with 10. Does the incoming tag match the native VLAN? It doesn't. It goes on the backplane of the switch as tagged. And finally, it arrives to our port 1. Now, port number 1 is configured to use VLAN 10 as the native VLAN. So now we compare the incoming tag with our VLAN, and they do match. So what switch is going to do is it's going to discard this tag, and it's going to send out the untagged frame out of this port. Now, the important thing to take out of this is that on the backplane of the switch, there are no untagged frames. So the only place where the native VLAN matches is on this link here. Now, even on this link here, the native VLAN does not have to match. So let me show you that configuration. So I'm going to go back to R1, and I'm going to change show run section 00. So this is the current configuration of my interface. So I'm going to go here, and instead of encapsulation.1q10 native, I'm going to use VLAN 1000 as native. So if I take a look at the configuration of the interface, this is what I have right now. What do you think? Can I now ping 192.168.10.2? What do you think is the answer? Yes or no? I liked one answer in particular. It was yes with a question mark, which is basically, yeah, I expect it to work, but I'm not entirely sure why. Well, let's give it a try. And of course, it's going to work. Now, it's going to work because R1's interface is configured that traffic that needs to go out in VLAN 1000 is going to be native. Now, the traffic that needs to go out is this traffic here. So this ping here, when it hits this sub-interface, we are saying, okay, so this is VLAN 1000, and this is actually native traffic. So send it untagged. So what is happening here on the wire, and let me use blue for that. What is happening is that the traffic is sent by R1 without the tag. And when it arrives to VLAN, to port number 1, it is going to get the same tag as that red traffic we had before. So it's going to get tag number 10. Now, the return traffic is arriving on this port with tag number 10, and the port is configured that the return traffic, which is in VLAN 10, as far as the switch is concerned, goes out untagged. So the traffic goes untagged to our R1, which is then received on an interface which is untagged. Basically, what we are telling the router is if you receive on this interface, on this physical interface, if you receive untagged frames, send them to this sub-interface for processing. This VLAN number here is irrelevant. Now, this is to answer one of your questions that some of you mentioned, that, and I'm seeing it here right now, is that you are going to get the native VLAN mismatch error. Well, here is cat1, here is R1. Am I getting any VLAN mismatch errors? I am not, because this is, and this is incidentally the exact same thing that I wanted to talk about now. That error message that we are all so familiar with is actually a switch-specific message. It happens only on switches. So now I'm going to go to cat1 and interface fastnet 24, and here I'm going to say that switch port trunk native VLAN is 40. Switch port trunk native VLAN 40. And let me create VLAN 40 on this switch. So let me change the VTP mode to transparent. So VTP mode transparent on both switches. Bear with me. So on cat2, I'm going to say no VLAN 40, but I am going to create VLAN 30. On cat1, I'm going to say no VLAN 30, but I'm going to create VLAN 40. So this is the configuration that I have on cat1 now, is that I have VLANs 10, 20, and 40, with 40 being native, and on cat2, I'm going to have show VLAN, and you will see that I have VLANs 10, 20, and 30, but I do not have VLAN 40. So in a sense, what I have created right now, let me copy this page. In a sense, what I have created now is that on this side of my connection, native VLAN is 30, and on this side here, the native VLAN is 40. So I do have this kind of unusual situation. So this side thinks this is native 40, and this side here thinks that the native is VLAN 30. And obviously, when you have this situation, what you are going to get is the CDP native mismatch. So if I go back to my terminal, I'm going to see this annoying error message that I do have this problem. Let me get rid of this message. So now I'm not actually going to get this message. This is a CDP error message, and you can see it here. It says that the CDP native VLAN is mismatched. Do you think, is our connection between R1 and R2 now working? Is it operational? Well, let's give it a try. So I'm going to go here, I'm going to ping in VLAN 10, and I'm going to ping in VLAN 20. This works like a charm. There is no problem with this communication. Furthermore, let me on cat1 create an interface in VLAN 40. I'm going to give it an IP address 192.168.101. No shutdown, and just for safety, I'm going to enable IP routing. On cat2, I'm going to create interface VLAN 30, IP address 192.168.102. So in the same subnet, no shutdown, IP routing. Do you think, can I from cat1 ping cat2? Will this ping work? There we go. I have to admit I didn't see this one coming. Let's see why. So, just want to make sure that spanning tree actually converged in VLAN 30. Of course. It is not going to work. And it is not going to work because the native VLAN is now in something that is called the port VLAN inconsistent state. So when you are running per VLAN spanning tree, I will talk about this later on a little bit. When you are running per VLAN spanning tree, the per VLAN spanning tree has a way to detect this situation, and per VLAN spanning tree thinks this is an error situation. But let's say that we are not running per VLAN spanning tree. So I'm just going to say spanning tree mode MST here. So if I do show spanning tree now, let's give it just a few more seconds. Show spanning tree. There we go. Show spanning tree on this side. So now we can see that there are no inconsistent states. And now if I run ping, 1 will be lost and then 4 are successful. And from that moment on, they're all successful. So basically what I have done with this configuration now, I have actually bridged these two VLANs. I'm running out of colors here, so let me see which one I can use. So basically what I have done here is I have bridged these two VLANs. So these are now in the same broadcast domain. So the fact that here I'm using VLAN 40 and that here I'm using VLAN 30, it doesn't matter, because the actual frames that are sent on this link here, even though they are coming from VLAN 40 on this side and they are coming from VLAN 30 on this side, they can actually communicate to each other. But from the control plane perspective, from the perspective of the spanning tree, especially Cisco's per VLAN spanning tree, this was an incorrect configuration. Now, there is a way around it. I use the MST, but what I need to explain is how this actually works. The question that I have here is, what is the function of the native VLAN? What Cisco IP phones are, they are switches. They are 3-port switches. Now, these 3-port switches, and you can see here on the back, now this is the slightly older model, but anyways, it doesn't matter. On the back of the switch, or the phone, we have 2 plugs. One says, connect me to the switch, and the other one says, connect me to a PC. Now, the idea here with Cisco IP phones is that we can connect them to the switch and then connect the PC directly to them. So what we have here is some central switch that has some port, and this goes somehow and goes to the wall socket. And in the wall socket here, we have RJ45 plug. So we can come in here with our phone, we can connect our phone to this device, and then we can have, from this device, we can connect to our PC. Now, when we have voice traffic, the voice traffic will be sent on the voice VLAN, and the data traffic here will be actually sent on the data VLAN. Now, I called it a 3-port switch because inside the phone, there is actually a 3rd port that actually connects to IP phone logic. So there are 2 external ports and 1 logical internal port. Now, what would happen if we had the exact same setup on another place where we didn't have the phone and instead we just simply plugged in PC to the wall? Would this work? Well, it could if we modified this port, or if this port was already configured to handle both situations, either PC directly connected or phone connected to the switch and then PC connected to the switch. Now, the way this works is that the data traffic is put in a native VLAN, and the voice traffic is put in a voice VLAN, which is tagged. That means that if we receive untagged traffic, we automatically know that this is supposed to be native traffic, or that this is the data VLAN. And if we receive the tagged traffic, we know that the traffic is from the voice VLAN. So this is just one use for the native VLAN. Another use is if you have, let's say, 2 organizations. For whatever reason, I'm just giving you an example. So I'm not saying that this is the right thing to do, but you could do. And these 2 organizations here have some sort of interconnection between them. But on this side here, this is, let's say, VLAN 100, and on this side here, this is VLAN 200. but they might want to have another logical connection here, which they agree is going to be in VLAN 300. Now, it's okay, for VLAN 300 we don't have a problem. We use the tag 300 here, and we use the VLAN 300 here. But let's say that on this side, VLAN 200 was used for something, and on this side here, VLAN 100 was used for something. So the VLAN 100 on this side is not the same as VLAN 100 on this side, and this VLAN 200 is not actually the same as this one. So what we need here is some way for these two VLANs to actually communicate to each other, or actually VLAN 100 on this side needs to communicate with VLAN 200 on this side, right? So we can't simply use the same VLAN tag on both sides. We actually need to somehow cross-wire the traffic. So one way of solving this problem would be to configure these as trunks, have VLAN 200 as native on this side and VLAN 100 native on this side, and that way VLAN 100 from this side will actually speak to VLAN 200 on this side and the other way around, while this VLAN 200 here is completely unaware that there is a VLAN 200 existing on this side, and the same thing in this direction. The third use case for native VLAN would be in a case that in your network you have devices that don't speak VLANs, which in 2013 is very unlikely to encounter. So these are the most likely scenarios in real life where you would be using native VLAN. Now, mind you, I'm going to repeat, I'm not saying that this is the right thing to do. This is actually a very wrong thing to do, because this interconnection in real life should actually be a layer 3 interconnect, but you know, who am I to pass judgment on what people do in their networks?